Hello, everyone. Sometimes in chemistry, a few concepts can feel a bit tricky. Well, today we're going to clear up one of the most important ones, the difference between physical and chemical changes. Trust me, by the end of this, you'll be spotting them like a pro. So, let's dive right in.
Just take a look around you for a second. Think about ice melting in a glass. Now think about a piece of paper burning. They're both changing, right? But something just feels different about them, doesn't it? So what is it that makes them so different? Let's figure it out together. So first things first, what do we even mean when we say change in science? It's actually pretty simple. It's any time a substance gets altered in its shape, its state, like from a solid to a liquid, or any of its properties. Imagine you have a ball of dough. You can flatten it, roll it, you're changing it. But it's still dough, isn't it? That's a change.
And here's the cool part. Every single change you can think of, from a tiny drop of water evaporating to a massive firework lighting up the sky, falls into just two main categories, physical and chemical. Getting a handle on these two is going to be your secret weapon for your exams. So let's start with physical changes.
So, Section 1, the physical transformation. Now, the big clue is right there in the name. These are changes that are all about the physical stuff, the outside. It's kind of like giving something a haircut or a new outfit. You're changing how it looks, but the substance itself, it stays exactly the same on the inside.
Okay, this is a big one. This is the definition you'll want to have locked in your memory. A physical change is a change where, and this is the most important part, no new substance is formed. And on top of that, it's usually reversible. You can almost always get the original thing back. It's like a round trip. You can always go back to where you started from.
So how do you know if you're looking at one? Well, you just have to look for these three clues. First, is the substance, deep down, still the same stuff? Yep. Water is always H2O, doesn't matter if it's ice, liquid water, or steam. Second, did only its form change, like its shape or its size? And third, the really big one, can you reverse it? If you can nod your head and say yes to these, you're looking at a physical change. See? Simple.
And you see these happening all the time. Tearing paper just makes smaller pieces of, well, still paper. And when you dissolve sugar in water, it might look like it's disappeared, but the sugar is still there. If you evaporated the water, you'd get your sugar crystals right back. The substance is still there, just in a different form. I bet you can look around and spot a few more examples right now.
All right, we've got a good grip on physical changes. Now, let's get to the really exciting stuff. Chemical reactions. This is where the true magic of chemistry happens. This is where we don't just change how something looks, we actually create something brand new, with totally different properties.
Now look at this definition. See how it's the total opposite of a physical change? In a chemical change, a new substance is always formed, and the process is irreversible. There's no undo button here. This is a one-way street, no turning back.
Think of it like this. A physical change is like changing your clothes. But a chemical change? That's a whole new you. You start with one thing, and you end up with something completely different, with a new name, a new identity, totally new properties. The thing you started with? It's gone. Forever.
We've all seen a piece of paper burn, right? You're left with some gray ash and smoke. Can you take that ash and turn it back into the paper? No way. That's a chemical change. Same thing when an iron nail gets left out and rusts. That reddish-brown flaky stuff, that's a totally new substance called iron oxide. It's nothing like the strong, shiny iron you started with.
Okay, it's time for the main event. The ultimate showdown, physical change versus chemical change. This is where we put everything side by side, which is going to make it super clear. So pay close attention because this kind of comparison is a classic exam question.
Let's just walk through this table together line by line. First up, the big one, new substance. For a physical change, that's a big no. For a chemical change, it's 100% yes. Okay, next, reversibility. Can you go back? For physical, yeah, generally you can. But for chemical, nope, not happening. Do you see the pattern? It really all comes down to whether you're creating something brand new or just changing its appearance.
Okay, I know that was a lot of information, but don't you worry. I've got a little trick for you. A simple rule that's going to help you tell the difference between a physical and a chemical change every single time. Here it is. This is your golden rule. All you have to do is ask yourself one simple question. Did I make something new? If the answer is no, and you still have the same substance you started with, it's a physical change.
But if the answer is yes, and you've got a brand new substance, it's a chemical change. It's honestly that simple. This is the key that unlocks any question on this topic.
All right, your turn. Time to put on your scientist hat. Think about the lunch you ate. When your body digests that food, is that a physical change or a chemical change? Here's a little hint. Your body uses enzymes to break down all that complex food into totally new, simple substances that it can absorb for energy. So, keeping our golden rule in mind, what do you think? Let me know your answer in the comments. And hey, if you found this explainer helpful, a like and subscribe would be awesome. See you next time.